Powers and exponents. Our objective is to evaluate expressions containing exponents. Why learn this? Biologists use exponents to model the growth patterns of living organisms. The base, in this case 3, is the number that is used as a factor. So your base is your bottom number. Your exponent, which is this 2, tells you how many times the base is used as a factor. So in this case, since it's a 2, it's like saying 3 times 3. So when a number is raised to the second power, we usually say it is squared. The area of a square is s times s, so side times side, which is the same as s squared. When a number is raised to the third power, we usually say it is cubed. The volume of a cube is s times s times s, so s cubed. Let's look at writing powers for geometric models. Write the power represented by each geometric model. Well, if we look at this one, we have a set of dots that is 3 by 3. So if we're going to multiply, we have 3 times 3, which would be 3 squared. In this case, we have 1, 2, 3, 4 by 1, 2, 3, 4 by 1, 2, 3, 4. So 4 times 4 times 4 is the same thing as 4 cubed. Let's practice reading exponents. 3 to the first power, which you often see as just 3. The 1 is assumed when 3 is by itself. 3 to the second power, or 3 squared, would be 3 times 3. 3 to the power of 2, and its value is 9, as when it's an exponent, it's saying 3 times 3. Now we have 3 to the third power, or 3 cubed. So 3 times 3 times 3, written as 3 to the third power. That has a value of 27. 3 to the fourth power is 3 4 times. So 1, 2, 3, 4 times. So we have 3 to the fourth power would be 3 times 3 times 3 times 3. And that is a value of 81. That is very different than saying 3 times 4 is 12. 12 and 81, very different values. When you're dealing with an exponent, it's this base that many times. And we have 3 to the fifth power, so we're going to have 3 5 times. So 3 times 3 times 3 times 3 times 3, 3 to the power of 5, which has a value of 243. Let's evaluate powers. So in this first one, we have the quantity -2, because it's all together. -2 is going to be written 3 times. So -2 times -2 is going to give you a +4. +4 times -2 gives you -8. Notice how in B it is written differently than in A. So in B, your parentheses, there are none. So you're putting 5 to the second power and keeping your negative off to the side till the end. Unlike in A, where it's -2 is to the third power. So we have -1 times 5 times 5. So 5 times 5 is 25, and then times -1 gives you -25. When dealing with a fraction, this exponent goes to both pieces. So the 2 goes with the 2 and with the 3. So it's 2 squared over 3 squared. Or you can think of it as 2/3 times 2/3, which would give you 4/9. If you did 2 squared, that would give you 4, and 3 squared, that would give you 9. So there's a couple of ways you can do that one. Let's look at writing powers now. So write each number as a power of the given base. So we have 8, and it has a base of 2. So if the base is 2, it's going to be raised to the 3rd power. Because we want a base of 2, that's going to give us a result of 8. So 2 times 2, that gets us to 4, times 2, that gets us to 8. So 2 to the 3rd power. Take a moment and try this next one on your own. Now that you've had a chance to try this one on your own, let's try it together. So we have a base of -5, and we want to find some way of getting it to -125. So if we start, we can do -5 times -5. Well, that's 2 negatives, so that means it's going to be a positive. So we know that if our answer is going to be a negative, we need an odd number of negative signs. So if we do 5 to the 3rd, we'll end up with 125, and since we have negative times a negative times a negative, we have an odd number of negatives, so only 2 of them will go away. The other one, it's going to end up staying there. So -5, that quantity to the 3rd power. Let's look at a problem-solving application. A certain bacterium splits into 2 bacteria every hour. There is 1 bacterium on a slide. If each bacterium on the slide splits once per hour, how many bacteria will be on the slide after 6 hours? Draw a diagram to show the number of bacteria after each hour. So we'll start with a diagram. We're starting with our first bacterium. After an hour has passed, we now have 2. Alright, well now 2 hours have passed, so each of those splits into another one. So now we have 4 bacterium. And then after 3 hours, each of those splits into 2. So notice that after each hour, the number of bacteria is a power of 2. So let's look at this a little bit more specifically. So after hour 1, we have 1 times 2, which equals 2, or 2 to the 1st hour. So we have 2 to the 1st hour gives us 2 bacterium. All right. After 2 hours, so we have 2 times 2, which is 4, or after 2 hours, we have 2 to the 2nd bacteria on the slide. Alright, well, let's look at the 3rd. Alright, so for the 3rd hour, we have 4 times 2, or 8, which would be 2 to the 3rd hour. So 2 to the 3rd hour gives us our 8. So after the 6th hour, what do you think you're going to use as a power? If it's 2 to the 1st hour, 2 to the 2nd hour, 2 to the 3rd hour. Well, we want 6 hours, so it's going to be 2 to the 6th for bacteria. So 2 to the 6th is simply 2 6 times, which gives you 64. So after 6 hours, there will be 64 bacteria on the slide. And that ends our lesson on powers and exponents.